IB Bio students. All right, today we're going to continue with 9.3 and we're going to look at tropisms. Now, the essential understanding says that plant shoots respond to the environment by tropisms. So what are tropisms? So tropisms describe the growth or turning movement of a plant in response to a directional external stimulus. So this directional external stimulus could be a different stimulus. So for example, in phototropism, the growth of the plant is in response to a unidirectional light source. So it's in response towards light. The plant is going to grow towards the light. In geotropism, which is also known as gravitropism, there is movement towards a response in gravitational forces. So in this case, the roots are growing towards gravity, and the shoot is growing against gravity. And in other tropisms, known as hydrotropism, you respond to a water gradient, and thigmotropism, you respond to a tactile stimulus or touch. So we are going to focus on phototropism and geotropism. Okay, because they are controlled by the distribution of auxin. And this is the one hormone that we are focusing on. So in geotropism, auxin will accumulate on the lower side of the plant in response to the force of gravity. And in phototropism, light receptors known as phototropins trigger the redistribution of auxin to the dark side of the plant. So remember that we saw this already in a previous section and how that happens. So let me quickly go back to that section. And if you remember here, if we said that if this plant was next to a light source that happened to be on the left side of the plant, right? Then the auxin efflux pumps were going to pump auxin from the left side of the cells to the right side of the cells. So there's going to be a greater accumulation on the right side of the cells where there's shade, which means that these cells on the right are growing at a faster rate, and they're going to elongate, which causes the plant to bend towards the left or towards the light. Okay, and then it's the opposite if the light source is on the right. All right, so let's go back. All right, so let's focus on how auxin affects the shoot and the roots a little bit different. So in shoots, I've told you before that auxin concentration promotes cell elongation. That means that the dark side of the shoot elongates and shoots grow towards the light. And this is what we refer to as positive phototropism. But in roots, high auxin concentration, that is going to inhibit the cell elongation. So we have antagonistic effects here. So in the dark side of the root becomes shorter instead of elongating, and the roots are going to grow away from the light. And this is an example of negative tropism. So let's see how this happens here in this picture. So here we see the root portion of the plant, and if there's an accumulation of auxin in that root, which will happen, it's going to inhibit the cell growth. And what's going to happen is that the auxin accumulation is going to accumulate in the lower cell layer. Okay. So then that means that this lower cell layer is going to be shorter than the top cell layer. So then that means that this top cell layer is going to force the root to turn down or away from the light. Okay? So the root is going to go down. And this is what we refer to as negative phototropism, because you're moving away from the light. Now, what happens in the stem or in the shoot? In the shoot is a little bit different because auxin stimulates the cell growth, right? It's an opposite effect. So now the lower cell layers, which happen to be on the side of the shade, these lower cell layers, they accumulate the auxin because the efflux pumps will pump the auxin towards the shady region. So then that means that the lower cell layers are going to elongate, and that is going to cause the plant to turn up and turn towards the light. So those are the different types of tropisms.